Hello everyone, welcome to my channel. In this video, I'm going to discuss the example for differentiation. Find the dy dx for the function y over x minus x squared multiplied with y is equals to 4. So kindly state the rules, especially the product rule. So where we have y prime is equals to v multiplied with u prime plus u multiplied with v prime. And we have a quotient rule where we have y prime is equals to v multiplied with the u prime minus u multiplied with v prime over v squared. So kindly refers to the situation y over x minus x squared y is equals to 4. So kindly let this one as u and this one as v. Differentiate the situation with respect to x. So by using the quotient rule where we have x multiply with the u prime where we have dy dx minus where we have u which is y. Differentiate the v with respect to x and we will have 1 over x squared. Next, focus on the second part where we have u and v. So minus with the bracket. Kindly make use of the product rule where we have v y multiply with the x squared multiply with the u prime means that differentiate x squared and we will have 2x plus we have x squared multiply with the v prime and we will have dy dx equals to 0. Rewrite the situation. Fx multiplied with dy dx minus y over x squared is equals to 2xy plus x squared dy dx. Multiply both sides with the x squared and we have x dy dx minus y equals to 2x to the power of 3 y plus x to the power of 4 dy dx. Rewrite the situation. So x minus with the x to the power of 4 multiply with dy dx is equals to 2 multiply with x to the power of 3 y plus with the y. So finally, the dy dx is equals to 2 multiply with x cubed y plus with the y over x minus x to the power of 4. Or you may rewrite your answer dy dx is equals to y multiply with 2x cubed plus with the 1 over x multiply with 1 minus x to the power of 3. Kindly refers to question B. If y is equals to 1 over square root of 2x minus 1, prove that y to the power of 3 plus dy dx is equals to 0. So kindly modify the situation where we have y is equals to 2x minus 1 to the power of negative 1 over 2. Kindly differentiate the situation. So dy dx is equals to negative 1 over 2 multiplied with 2x minus 1 to the power of negative 3 over 2. Do remember to differentiate the internal function and we will have 2. Rewrite the situation. So dy dx is equals to negative multiply with 2x minus 1 to the power of negative 3 over 2. So rewrite the situation. So dy dx is equals to negative bracket 2x minus 1 to the power of negative 1 over 2 bracket where we have power 3 Kindly observe to the situation where we have y is equals to bracket 2x minus 1 to the power of negative 1 over 2. So from here, we notice that we have dy dx is equals to negative y to the power of 3. Rewrite the situation where we have y to the power of 3 plus dy dx is equals to 0. Proof the situation. C. Evaluate the value of dy dx at the point x equals to 5 and y is equals to negative 1 on the curve where we have 4y squared plus 3 multiplied with xy plus x squared equals to 14. Kindly differentiate the situation with respect to x. So we have 8y dy dx plus with the situation where we have u and v. Make use of the product rule. So where we have y multiplied with 3 plus 3x multiplied with the dy dx plus 2x equals to 0. Kindly substitute the value of x equals to 5 and y equals to negative 1, where we will have negative 8 dy dx minus 3 plus 15 dy dx plus with the value 10 equals to 0. Kindly simplify the situation and we will have 7 dy dx. If we simplify this part and we will have 7 and rewrite the situation and we will have negative 7. So dy dx is equals to negative 1 at the point 5, negative 1. Thank you so much for watching this video. If you think the video is useful, kindly consider to like, comment, share and subscribe.